Hi. So I'm pretty excited about this one. I finally figured out how to take advantage of Delaunay triangulation for creating voronoi diagrams, and that opened up the possibility for doing voronoi relaxation, um, which it's pretty cool. Let me get through some of this stuff here first. There's a bunch of other experiments I was doing too with like ray tracing and stuff, but it didn't work. No, this does work. Um, so now we can use the mouse wheel to zoom in and out. We can zoom way in. We can zoom way out. We can use mouse wheel button to move around, which is nice. C to reset camera, R to reset simulation. We got debug. This is great for the editor, which uses the same base for main, but it's not really being used here. This is another debug. This shows a unique color for each section that, like for each pixel, the color is determined by whatever part of the geometry is closest. And you get these white sections for the parts where it's 2 or more, or not at all, or I don't know. It's an unusual case. Let's see here. I used the signed field generator to generate this outer line and this inner line, and this inner line is actually what's being used to contain our points here, but you can see that their edges are just coming in contact with the with our target shape, the shape that we plugged in. Let's get rid of that signed distance field, and then this is the really fun part. There's this debug stuff. I gotta remember though. I think F9 breaks it. Okay, it didn't break. Weird. Well, it's meant to delete everything, but anyway, F10's supposed to do something too, I think. I don't remember what. I can change the rate of the simulation. There's a little notification for that. I just put that in and it needs some work. I wanted to put it up here, but whatever. Anyway, that exponent determines how rapidly things go, and it'll be much more responsive as a result. Oh yeah, you can do this now, by the way. I was trying to save it, but ta-da! Anyway, yeah, so it becomes less and less responsive as you bring that exponent down, but as a result we get much cleaner output, less of this vibration. And you can see that as we go down, things start to shift and kind of settle. It's very, very subtle, but if I mess with this a bit more, you'll see what I mean. Right there, everything just kind of stopped. And then do it again, and then it moves a little bit. And again. There we go. See, that stuff all shifted because of me reducing that. And again, and again, and again. It's like cooling a metal, I guess. Like a really hot metal, and the process of hardening it sets everything in place. Kinda. Debug, the debug. Let's start with the Sorry, my brain's not working. Give me a second here. Delaunay. It's probably Delaunay, but anyway, this is the Delaunay triangulation, and I know that I saw things about this before, but you can use this to generate a voronoi diagram. I just didn't realize how easy it was. Another thing I did here was I made it so that all of the triangles, they never actually touch. I mean, okay, they are touching in memory, technically, but the way that they're rendered, I deliberately made it so that there'd be the vertices would be inset slightly towards the centroid of the triangles, and that would make it so that they don't actually touch each other visually, and that's to help to distinguish them. But the effect is more pronounced depending on the size of the triangles, and in this case, this sort of windmill thing that's going on here is it's the super triangle. That's part of how the algorithm works, but the only reason I have it spinning like this is so that I can ensure that my output is not affected by some sort of bias that's being created, because the super triangle, I think it's technically supposed to be infinite in size, but I don't want to deal with that, so I just made it really, really big. So here's the really fun one. You can actually see the triangles that compose the cells of this. There are other cells that you can't make out here. I don't know why exactly, but I know that they're supposed to be connected to this outer shell. They're supposed to be triangles that go like across this way. I think we can actually see those if we go into the yeah, like this. You can see how the Delaunay triangles cross over from these points to this outer geometry. So there's supposed to be something here, but I don't know why it's not showing up. I'd have to take another look at my code, I guess. This is the cool one, though. This is where it gets really interesting. I can go like and break it. My grandma managed to break my code a few times already now. It has a flow to it, and it's kind of squishy. And I think this would be a really, really good way to do. Well, I guess basically what I was trying to do this whole time was voronoi. Relaxation, or Lloyd's algorithm, as it's sometimes called. But yeah. No, I'm sorry. I'm having a little too much fun with this. It's neat. I like watching like the shapes kind of appear and disappear as things move past each other, like this. Like bam. See, there's like this. There's this triangle. These two triangles here that turn into these two triangles here as this moves through. And just that kind of thing. It's just that. Oh, it's so cool looking. Of course, I have other shapes. Let's see here. Let's be boring and do a square. More on the wall, more! I swear every time I force one in, another one leaves. No! It automatically tries to sort of balance itself, which is great. Unfortunately, it's still not perfect. You can see that there's still contact here, for instance. I'm still figuring that out. It's mesmerizing. I love it. Alright, I'll do one more. Let's do... Oh, hollow... Triangle? And let's go with something a little more dense. More. Whoa, uh-oh. Okay, my code's a little buggy still, clearly. I don't know what's going on. Okay, this shape is cursed, apparently. Let's try... hello... circle. It's a bubble wrap shape generator. And again, you can see that these, what I've done is I've got my, I don't know if I actually said this yet or not, I probably did, but the idea here with the signed distance field and using marching squares was to make it so that I could inset our target shape the distance that is the radius of one of our circles here, so that the edge of it just touches our shape. And this is going to help with simulating, or basically just it's like meshing our shape, remeshing it for simulations. Which is kind of funny. I think you could technically argue that I'm using a simulation here to optimize this, but you know, a matter of perspective, I guess. I'm gonna slow it way down. Oh, there we go. Faster. Okay. Oh, something's going on there. I'm having too much fun. Sorry, this is neat. It's pretty nifty. You can see that the triangles here for both the Voronoi diagram and the Delaunay triangulation, there's a lot of intersections that are at right angles, and that's not a coincidence. Alright. I should get going. Thanks for watching.